Hi, good morning, good afternoon. Welcome to the annual webinar sponsored by the Crash Modification Factors Clearinghouse. If you can believe it, the CMF Clearinghouse has been around for 10 years, almost exactly to the date today. So I think we launched the Clearinghouse on December 1st, 2009. So we've been around for about 10 years, and every year we try to sponsor a webinar to share information and education about crash modification factors. This year's webinar is on CMF how-tos, including planning, multiple treatments, and API. Oh my. My name is Karen Scurry, and I'm with Federal Highway Administration's Office of Safety, where I am responsible for the Highway Safety Improvement Program as well as the CMF Clearinghouse. We have a full agenda planned today, starting with an overview of CMFs and the CMF Clearinghouse with Taha Saleem, who is the manager of the CMF Clearinghouse. Followed by Taha, we'll have Frank Gross with VHB, who will share resources on combining CMFs for multiple treatments, including the issue of independence. Then we'll hear from Matt Hinshaw with the Federal Highway Administration's Office of Federal Lands Highway, and he'll talk to us about how they're using CMFs for project planning and identification at federal lands. And then last but not least, we'll hear from Shanshan Zhao from the University of Connecticut about how they were able to link to the CMF Clearinghouse in their new safety management tool using the new API feature that we published through the Clearinghouse earlier this year. Before we get started with today's webinar, I wanted to go over a few housekeeping items and the functionality of the webinar software. So if for some reason your computer or web browser freezes during the webinar, please just reload the website and log back into the program. You should be able to rejoin the session, no problem. All the phone lines today are muted during the webinar. We're expecting a large number of attendees on the call, and so muting your audio helps us to cut down on any confusion or background noise. So as an attendee, you have a control panel in the upper right corner of your screen that collapses and expands by clicking on the red arrow. And even though your lines will be muted, you will still have the ability to ask questions by entering them in the question box in that control panel. So please feel free to ask questions about any of the presentations as we go along by typing them into that box. It would be very helpful if you maybe start with the name of the presenter and then ask your question, because we are going to hold all the questions until the end of the webinar, and that will help us direct them to the correct presenter when we get to the question and answer period. If you have any problems during the webinar, you can also enter that here. We will be monitoring these questions and can respond to you if possible to see if we can help with whatever problem you might be having. I also wanted to note that we're recording today's session, and we'll post the recording, the PowerPoint slides, and written responses to the questions on the CMF Clearinghouse website within the next couple of weeks. So in case you have to jump off earlier or you have a colleague who wasn't able to join us today, that information will be available on the Clearinghouse website. So to help us gauge the number of people attending today's webinar, we want to do a quick poll to see how many people are attending the webinar from your location. And so, Caroline, I think you're going to bring up the poll. There we go. So this is a multiple choice question. So if we're asking you to respond to how many participants are attending the webinar at your location, your options are 1 participant, 2 to 5 participants, 6 to 10 participants, 11 to 20 participants, or maybe you decided to have a party and you have more than 20 participants with you watching the webinar today. Great, thank you. Thank you for your responses. I know we had over 300 people registered for the webinar today. It's really exciting to see so many people interested in learning more about crash modification factors. So with that, I think we'll get right into it with the first presentation, which is an overview of CMFs and the CMF Clearinghouse. And so as you may recall, when you registered for the webinar, some of you also submitted questions in advance. And so Taha hand-selected a couple of these questions and will review those questions and the answers to those questions in his presentation today. And then some of your other questions will be addressed through the other presentations. And then if we don't get to your question today, similar to any questions that you ask in the chat box, we will provide written responses and follow up to the webinar. So before I turn it over to Taha, I would like to formally introduce him. I mentioned as I went through the agenda that he's the manager for the Crash Modification Factors Clearinghouse. He's new to this role, and so I wanted to just formally introduce him to everyone so you know who to reach out to regarding the CMF Clearinghouse. So Taha Saleem is a research associate at the UNC Highway Safety Research Center. His research interests lie mainly in the application of state-of-the-art statistical methods in road safety. He completed his doctorate in civil engineering from Ryerson University in Toronto in 2016 and has been involved in several safety evaluation research projects for NCHRP, Federal Highway, and North Carolina DOT that involve development of robust SPFs and estimating CMFs. He's also involved in NCHRP 1772, the update of crash modification factors for the Highway Safety Manual. So as you can see, Taha has a wealth of experience in CMFs and has been working with the CMF Clearinghouse for a couple of years now. So welcome, Taha. As the CMF Clearinghouse manager, he's responsible for the day-to-day operations of the CMF Clearinghouse. And now I will turn it over to Taha for his presentation. Thank you.
Thank you, Karen. So guys, now we will be talking about the process of selecting and applying CMFs in my presentation. So selecting an appropriate CMF for your particular scenario is very important, However, applying your chosen CMFs correctly is equally as important as well, as it can have a large impact on the results. Now, in the next few slides, we will cover different topics such as dealing with too many search results while you search for in the clearinghouse, differentiating between and applying multiple CMFs, and also calculating the reverse treatment effect. Now, before I dig deep into those different questions, I would like to mention here, that our CMF Clearinghouse team is available to help explain the CMFs that are available on the Clearinghouse website or from a specific study report. So if you have any questions, please feel free to reach out to us, and we'll do our best to assist you in understanding those CMFs that are available out on our website or in a specific study report. So with that, I'll dig straight into one of the first questions that we're dealing with today. It is dealing with too many search results. So generally, there are multiple ways that you can narrow down your search results in the clearinghouse. And one of the ways to narrow down your search results is by using more terms in your search. So we can see from the first screenshot that I have at the top here, that searching for the term edge line only, for example, it returns 404 CMFs. Now, this can be a bit overwhelming to go through, these 404 CMFs and find the specific CMF that fit your needs. However, if you see the second screenshot at the bottom, just, using a specific term such as edge line width, your search results are now reduced to 54 CMFs, which is, a lot more manageable than the 404 CMFs that you got when you search the term edge line only. Now, an alternate way to narrow down your search results is also by using the filters that are present on the Clearinghouse website. And so if you use the same example as we used in the last slide, where we had the edge line example, which returned to us 404 different CMFs. So if you're on the website, on the search result page, you can see the different filtering options on the left side of your screen in the white box. Now, if you go further down, so I provide 3 different examples of how you can use those filters. So the first one is, you can filter by the star quality rating. So in this case, you can see, if you mark the checkbox next to 4 and 5-star CMFs, you will come down from 404 CMFs all the way down to 116 CMFs. Alternatively, you can also filter by different crash types. So in this example, you can see, filtering for run off-road crashes only would result, in a list with 219 CMFs compared to the 404 that you started with. We can also filter by crash severity in this case, if you filter by K and A crashes, which are the fatal and serious injury crashes, your resulting output would be 357 different CMFs. So depending on your needs, you can start your search with a broader term and then filter down your results using the filtering tool, or you can start with a concise term and still use the filtering tools, to filter down and pinpoint the CMF, that you would like to use for your scenario. So going forward, there you may run into instances, where you may find multiple CMFs for the same crash type and severity in the study. Now, it is very important to understand the differences between such CMFs and how to differentiate between them. So let's give you an example, So here's examples where you can see there are two CMFs for total crashes in the same study for providing a left turn lane on one major road approach in urban areas. Now, to make it easier to identify the difference in such cases, because if you look at just this search screen, you cannot figure out, what is the difference between those two CMFs, because they both deal with total crashes with all severities in urban areas. However, there's difference of points CMFs between the two. One is 0.73, one is 0.76. So you can identify differences in such cases by using the Compare CMF tool that is available on the Clearinghouse website. So to compare, you simply have to check the boxes corresponding to the CMFs you want to compare and hit the blue compare button that you see at the top left portion of your screen right now. Once you do that, you'll have a screen like this, where the blue highlighted rows identify the differences between the two CMFs. So in this particular case, you can see that one of the CMFs, that for providing the left turn lane on a major road approach, looked at the stop control intersections, whereas the other one looked at the signalized intersections. So now what does the 0.73 CMF applies to and what does the 0.76 CMF applies to specifically. Now, in some cases, differences might not be obvious from the data feeds, that are available in the Clearinghouse. But rather, you will have to look at the comments box where the reviewer enters important notes about the CMFs. So in this particular example, for converting HOV lanes, which are high occupancy vehicle lanes, to high occupancy toll lanes, HOT lanes, it can be seen that the difference between these two specific CMFs, it can be found in the comment section, which identifies that the first CMF of 0.96, it specifically looks at the entire roadway section, while the second CMF, which is 0.72, it looks at only the HOT lanes on the section of the roadway. So yes, so now going forward, our third question we'll talk about would be calculating the reverse treatment effect. So let's assume a scenario, where a study indicates a CMF of 1.48 for a 75-degree intersection compared to a 90-degree intersection. So the question here is, what is a reasonable assumption of CMF for realigning an intersection to 90 degrees? So assuming that a 1.48 CMF would lead to a 52% reduction in crashes when an intersection is realigned to 90 degrees, maybe because 2 minus 1.48 is 0.52, is incorrect. It's a mistake. The correct way to do it, is the CMF, is generally calculated as the CMF for the new condition, which in this case would be the CMF for 90 degrees, and you divide that by the CMF for the old condition, which would be, in this case, CMF for 75 degrees. So in short, you get 1 divided by 1.48, it's 0.68, and effectively, that shows that you'll have a crash reduction of 32% and not 52%. So we should be very careful, when we are trying to imply the reverse effect of any treatment and make sure, we use the right methodology, to do so. Now, let's talk about applying too many CMFs without accounting for interrelationship of effect. So various CMFs, in the Clearinghouse, you'll see, they address the same crash type. So for example, you can have CMFs addressing runoff road crashes at curves, and there can be various countermeasures, that will address runoff road crashes at curves. That can include chevrons, wider edge lines, or high friction surfacing. Now, of course, these effects are related, but we have to understand that they are not independent of each other. So how do you deal, when you have multiple CMS available. One of the options is, you multiply the CMFs together, which would likely end up, in overstating the benefits of those treatments. So hence, accounting for interrelationship of effect becomes very important. We can also take a conservative approach where, we use the CMF from only the most effective treatment. So I won't dig deep into this in my presentation because there's more detailed discussion on this topic coming up in the next presentation, and you'll learn more about how you can combine multiple CMFs to get a combined treatment effect. So at this point, I would like to ask you, if you have any questions, you can enter it using the GoToWebinar questions window. And for the next presentation, we'll have Frank Gross from VHB, and he will be discussing about the resources on combining CMFs for multiple treatments, including the issue of independence. So Frank, I think we will transfer the controls to you now.
All right, sounds good. Can you hear me okay, Taha?
We can hear you okay. And just let us know, once you have them. Yep, so we can see your screen now. That's good.
Perfect. All right, thanks everyone. I guess we'll start off. I'd like to start off with a few questions. So some of the questions we need to ask ourselves is, can you use CMFs to estimate the combined effect of multiple countermeasures? And assuming that you can, what methods should you use to estimate the combined effect? So can you add the CMFs? Can you multiply the CMFs? Are there other more appropriate methods? And I'm going to try to address these questions in my presentation today. Ideally, if we were living in an ideal world, a CMF would be available that represents the effect of the combined treatment. And if that's available, in some cases it may be, then it's relatively easy to use that single CMF to estimate the change in crashes for your scenario that includes multiple countermeasures. So just as a short example, the CMFs that are shown here in this table are available in the CMF Clearinghouse, and these represent the combined effect of multiple countermeasures. So something like shoulder rumble strips and shoulder widening has a CMF of 0.61. And then you can see down through the rest of the list. In reality, though, we don't always have that ideal scenario, and you may need to use the kind of multiple CMFs for the individual countermeasures to estimate the combined effect. And as far as I can tell, there are not CMFs available for the combined effect of these individual countermeasures. And if you wanted to install, for say, a left turn lane and improve intersection sight distance, then you're going to have to somehow combine or use the individual CMFs to estimate that combined effect. So we have CMFs for installing left turn lanes, we have CMFs for improving sight distance, but we don't have one for that combined effect. So really the question is how to estimate that. There's a number of potential methods to do so, and the Highway Safety Manual suggests the multiplicative method. At least the first edition of the HSM does. The second edition is likely going to include the methods that are explained in today's presentation and in some other resources. But that multiplicative method was kind of where we started, and it's relatively simple in that you just multiply the CMFs together, but the issue is that it may or may not be a reasonable estimate of the combined effect. So other methods have been proposed and considered, such as the additive method, the dominant effect method, and the dominant common residuals method. And these may provide a more reliable estimate depending on the scenario at hand. So really the million-dollar question here is, when would you select one of these methods over another? And I'll walk through a process to help identify and answer that question. So hopefully I can help to shed some light on these different methods and when it may be appropriate to apply one over another. And really to find the most appropriate method, you'll need to follow this 4-step selection process. So the first step is defining the scenario of interest. And in doing that, we want to not only define the countermeasures that we're going to be using, but we want to consider how they're going to be applied in that scenario. So as part of this step, you'll need to define the general conditions, and those can include the roadway characteristics, the traffic volumes, and those are going to help identify an appropriate CMF for those countermeasures. But for each of the countermeasures, you also want to define the target crash type and severity, the applicable time of day. Is this countermeasure applicable during the day, during the night, both? And the specific portion of the road where that treatment will be applied. So is this countermeasure applicable to the entire location, or is it for one direction of travel or another? So if, for example, you were planning to construct a roundabout at a stop-controlled intersection, that's going to impact the crashes on all approaches. So that's kind of an entire location impact. But if you were installing a treatment on one approach of an intersection and that was only for maybe wet weather conditions that you were trying to target, then that may have a very local impact and not impact crashes on all approaches or for the entire intersection. So you want to consider that applicable time of day and applicable location as well. So that's really defining the entire scenario of interest and thinking about how the treatment could impact crashes. The second part is to understand the limits of the combined effect. And I'm kind of representing some different scenarios here with different mathematical equations. And only one of these is incorrect as it applies to multiple CMFs. And I'll go through each of these a little bit, but as you're looking through those, try to figure out which one of these may be incorrect as you were considering the multiple effects of treatments. So in case A there, we see that 1 + 1 is 2. That's, I guess, mathematically correct. I'm sure someone could argue against that, but mathematically, let's say that's correct. And it's also correct in our scenario because you could recognize or observe the full effect of two treatments. So let's say you have two countermeasures, you're expecting the full benefit of both of those. We would then estimate the combined effect as the full effect of the two. So let's say in this case, case A is good to go. That's a correct answer. In scenario D there, that's mathematically incorrect. 1 + 1 is 3. We just said 1 + 1 is 2. 1 + 1 = 3. Not mathematically correct, but in this scenario, you could have that be correct if two countermeasures enhance the effect of the other. And I'll give a brief example. Let's say we're considering shoulder rumble strips and shoulder widening. And these two countermeasures individually have a benefit, and together they might produce more of a benefit than the two individual effects combined, because the added shoulder width could provide more recovery room for drivers that hit the rumble strip and are alerted by that. So it may give them some additional room for recovery and may enhance the effect of the rumble strips on a narrow shoulder. So let's say that D is a possibility here. Another one is B, so 1 - 1 = 0. That's also correct mathematically and in this case, because you could start with an average of 1 crash per year at a location and implement a countermeasure to eliminate all potential crashes, which would result in a total crash reduction. So maybe that's not completely realistic. Maybe we don't have countermeasures that would eliminate all crash risk, but it is possible to recognize the full benefit of a treatment and have a 100% estimated reduction. In this case, the estimated or the incorrect option here is C. So you can't reduce more than 100% of the crashes. And that's the key thing to keep in mind as we're combining CMFs to estimate the effect of multiple treatments. So if you started off with 1 crash per year on average, you can't recognize 100% benefit being 1 crash for countermeasure 1 and 100% benefit for countermeasure 2 and get more than a 100% reduction in crashes. Not possible. So moving forward, we're going to keep in mind that the maximum effect of any countermeasure or combination of countermeasures is a crash reduction of 100%. Step 3 is determining the potential for overlapping effects. And this is another critical part of the process. And the potential for overlap is defined with respect to target crashes. And this represents the likelihood that the two countermeasures would address the same crash types. And the important distinction here is that this is different from the applicability of the CMF. So if you're looking at the CMF applicability, that it's not necessarily the same thing as the target crashes of the countermeasure, and I'll go through a quick example to explain that. But these are two things to keep in mind, two key words here, and I hate to introduce very specific terminology, but keep in mind the difference between target crashes and the applicable crashes related to the CMF. So in this example, let's say an agency replaced a minor road stop-controlled intersection with a roundabout, and what they're targeting are the angle crashes. So with the roundabout, you're still going to have potential for sideswipe and these merging crashes, but what you're really doing is hoping to eliminate the right angle crashes. And then separately, a researcher comes along and they develop a CMF that applies to injury crashes. So that's the applicability of this specific CMF of 0.13 is injury crashes. The target crashes, however, may have been something different, which in this case could be right angle crashes. So that's just an example of the difference between target crashes and applicable crashes as we move forward. So continuing with the potential for overlapping effects, in this scenario, let's say we're considering lighting on the major road and advance warning signs on the minor road. And this is at let's say a two-way stop controlled intersection. The question here is, do you think there would be no overlap, some overlap, or complete overlap? So think about that for a second. We have major road lighting, minor road advance warning signs. I think in this case, the answer is always, it depends, and there's going to be the need for judgment here. But I think it would be appropriate to assume some overlap in this case because both the lighting and the advance intersection warning signs are going to help alert drivers, at least those on the minor road, to the presence of the intersection at night. However, the signs will also alert them during the day. The lighting would also have some impact on the major road. So they're probably not going to completely overlap, but there's likely some overlap here, and I wouldn't expect maybe the full benefits of each because of that potential for overlap. So again, judgment is really going to be critical in this process. And we have 5 different scenarios that we could identify as the potential overlap. So your 2 countermeasures may complement, replace, or counteract each other. And your job through this process is really selecting the case that best matches your scenario. So 0 overlap represents really 2 independent effects. So you're going to expect the full benefit of each countermeasure. And that's what the multiplicative method assumes in the Highway Safety Manual, that the 2 treatments are independent, we can assume the full benefit of each, and we move on. Complete overlap is when you have 2 non-independent effects, and the second countermeasure is really targeting some or all of the crashes that the first countermeasure was addressing. So if you widen the lanes and widen the shoulders, you may be targeting the same runoff road and opposite direction crashes. So in that case, there may be complete overlap. I think in many cases, you're going to have some overlap, and that's when both countermeasures provide a benefit, but the second countermeasure may have a reduced benefit because the first countermeasure had addressed some of the target crashes already. So let's say we installed a cable median barrier and shoulder rumble strips on the left shoulder or the median shoulder of a 4-lane divided highway. In this case, the cable median barrier and the inside shoulder rumble strips would both target cross median crashes. But there may be some added benefit here because the shoulder rumble strips are also going to target the runoff road left crashes that would not have resulted in a cross median crash. For the enhancing effect, I mentioned previously that if the combined effect is greater than the sum of the individual effects, then this is considered an enhancing effect. And I gave the example of shoulder widening and shoulder rumble strips. But on the contrary, you could also have counteracting effects, which is where one countermeasure negates the effect of the other. And let's say that it's not necessarily a countermeasure, but let's say we were faced with a design exception and had to reduce the radius of a curve, but then we installed advanced curve warning signs and chevrons to counteract that. I would consider those counteracting effects. So keep those in mind as we move forward. And here's just another example of that. So we have two scenarios here, but to determine the potential overlap, you really have to consider the crashes and the locations that are targeted by the countermeasures. There's going to be more potential for overlap if the individual countermeasures either target the same crash types or are applied to the same locations. So again, if you were, let's take the example on the left, if you were installing advanced intersection signs on the side roads and improving sight distance, trimming the vegetation in all four corners, then there's likely a high potential for overlap because both treatments target similar crashes and they're targeting the same approaches as well. In this scenario on the right, let's say you're considering two improvements on a multi-lane divided highway. If one of those improvements is cable median barrier, that could impact crashes in both directions. And those would be kind of your cross median crashes. And let's say you were also considering widening the clear zone here on the south side. That's pretty much going to target the runoff road to the right crashes for the vehicles traveling from left to right. So there may be reason to think that there's pretty good independence between those two countermeasures because they're applied to different locations and they're targeting different types of crashes. Now you may argue that and have some judgment and say there could be some cross median crashes that would come over and hit a tree, so there could be some added benefit to that. But again, that's where the judgment comes into play. So the last step of that four-step process before I get into the methods more is categorizing the magnitude of the individual effects. And this doesn't have a huge impact on the method you select, but it is something to keep in mind. And depending on the magnitude of the individual effects, the method you end up selecting may have a nominal or a significant impact on the combined estimated effect. So if both countermeasure effects are relatively small, let's say 5% change in crashes for both countermeasures, whatever method you select probably isn't going to make a huge difference in the result. But as the effect size increases, the methods tend to produce much different estimates, and then it becomes more important to select an appropriate method. So this table simply serves as a guide to categorize and understand the relative magnitude of the individual effects. So at this point, we've considered the potential for overlap, we've defined the magnitude of effects, and now we can use this table to select an appropriate method. So this table assumes that the CMFs apply to the same crash type and same crash severity. If they don't, if one CMF applies to total crashes, the other CMF applies to, say, fatal and injury crashes, there's a different process that we need to use, and I'll explain that in a little bit. But let's assume that we have two CMFs and they both apply to total crashes. You would start with this table and assess the magnitude of the CMFs. So if one or more CMFs is greater than one, then the multiplicative method is appropriate. If both CMFs are less than one, then the additive, dominant effect, or dominant common residuals method may be appropriate, and we have to figure out the potential for overlap. So if you expect no overlap or enhancing effects, then the additive method would be appropriate, and that basically assumes the full effect of both countermeasures. And you have to caveat that with, you can't have more than 100% reduction in crashes. So we would keep that in mind using the additive effect. If you expect complete overlap, then the dominant effect method is generally going to be the more reasonable estimate. And in that case, you would select the CMF that represents the greatest effect. If you expect some overlap, then the dominant effect or the dominant common residuals method may be appropriate. And basically, you apply the two methods and take the better result, and the better result being the one that gives you the greater reduction in crashes. So I think maybe an example would help to illustrate this. So in this scenario, we're considering two countermeasures, which are a two-way left turn lane and reducing the driveway density along a corridor. The CMFs are shown here. They both apply to all crash types. They apply to all crash severities. They apply to the same type of roadway facilities, so we can combine those using the methods in the previous table. So I'm going to back up one slide. So keep these two CMFs in mind, 0.8 and 0.89. So both CMFs are less than 1. So we can rule out the multiplicative method, and we're down here in the bottom section. And now we need to consider the potential for overlap. So if you expect 0 overlap or enhancing effects, again, the additive method would be appropriate. I don't personally think that that would be the case here for two-way left turn lanes and reducing driveway density. But I also don't think there's complete overlap. So the dominant effect method, I don't think would be the most appropriate. I would say there's likely some overlap in those two countermeasures. So we would test out the dominant effect and the dominant common residuals and see which one works best. Now, the dominant effect method tends to work well in this scenario when both effects are large. That's not the case here. They're 0.8 and 0.89, I think. But let's see how this would play out. So I'll go back to the next slide, if I can do that. So in this case, the dominant effect method, we would select the CMF of 0.8. The dominant common residuals method, if we apply the equation, it's CMF1 times CMF2 raised to the power of CMF1, where CMF1 is the larger reduction, so it would be the 0.8 here. So applying that method, we would get a combined effect of 0.76. So in that case, 0.76 is a larger effect than 0.8, so I would take the result of the dominant common residuals method and use that as my combined effect. So that's how that thought process works, or the selection process works. So if the CMFs apply to different crash types or severities, you'll need to use this 5-step process. And I'm not going to go through this in detail. There's some additional resources that can help you out with this. But the key is really to apply each CMF individually to any crashes that are related to that CMF. And then if there's any crashes that are kind of related to both CMFs, you would figure out which method to use from the previous table and apply that CMF to the overlapping crashes. And I think maybe an illustration might help to explain that a little better. So in this first graphic, the outer rectangle, that thick black rectangle, represents the total crashes for our site. And we can divide those crashes up into subsets or crash groups. So in this case, we've divided into 2 crash groups, 1 and 2. And let's say CMF1 applies completely to crash group 1, CMF2 applies completely to crash group 2. We would apply those CMFs kind of in parallel to those individual crash groups, and then we would combine the results at the end. So let's say numerically, for an example, we had the total crashes at a location were 9 total crashes, and those were broken down into 3 crash groups. Crash group 1 was 3 cross-median crashes, crash group 2 was 4 runoff road right crashes, and crash group 3 were 2 sideswipe crashes. And we have our 2 countermeasures, countermeasure 1 and countermeasure 2. And countermeasure 1, or the CMF for countermeasure 1, only applies to the cross-median crashes. The CMF for countermeasure 2 only applies to the runoff road right crashes, and neither of those applies to the sideswipe crashes. So what we would do is, just like applying any other CMF, we apply the CMF to the applicable crashes. So the 0.87 is applied to the 3 cross-median crashes. The 0.93 is applied to the 4 runoff road right crashes. And there's no CMFs for sideswipe, so we assume no change in those crash types. So we're just left with the 2 sideswipe same direction crashes that were there before. So those are the crashes with treatment. And then we can take the difference. So if we had 3 cross-median crashes without, minus 2.61 cross-median crashes, or cross-median crashes with, we would get a benefit of 0.39 crashes per year, or per whatever our study period is. So we take the difference in all 3 crash groups. Again, we get no benefit on the sideswipe crashes since the countermeasures didn't address that crash type. And now we can add up those individual benefits, 0.39 plus 0.28 plus 0, and that's going to give us our total combined benefit of 0.67 crashes per whatever the study period may be. And again, the last thing is to confirm that that combined effect is not greater than the total number of crashes, which was 9 crashes. So in this case, we're good. We assume a combined effect of 0.67 crashes, and we can carry on with our analysis. So that was a fairly simple example where the two countermeasures apply to separate crash types and severities. An extension of this is illustrated here where CMF1 applies to 2 crash groups. So in that case, you would apply CMF1 to crash group 1 and 2, and then separately apply CMF2 to crash group 3, take the difference in the benefit and add up the benefits at the end, and you get your total estimated benefit. In this case, you have 3 crash groups again, but the 2 CMFs both apply to they have some overlap. So there's overlap in crash group 3. And in this case, what I would do is I would apply CMF1 to crash group 1, CMF2 to crash group 2, and then use our methods from before to figure out what the effect would be on crash group 3. Should I use the dominant effect method, the dominant common residuals method, the multiplicative method, or the additive method, and apply that to crash group 3, and then sum up the results and get our combined effect. So we're not always multiplying or combining the CMFs. We may be applying them separately and combining the benefits to estimate the combined effect. So that's another, I think, key takeaway there. All right, so just to wrap up, let's revisit the questions we started with. The first question, can you use CMFs to estimate the combined effect of multiple countermeasures? The answer, I think, is yes, but ideally you would use a CMF that represents the combined effect. Assuming that does not exist, then follow the process that we went through here to select an appropriate method and then apply that method accordingly. What method should you use? Again, it depends. One thing I can say is that we're not going to add CMFs together. There is an additive method, but I just want to be very clear that this does not add the CMFs. It adds the benefits or those percent reductions and caps that reduction at 100%. The multiplicative method, again, may be appropriate in certain cases, especially when one or more of the CMFs are greater than 1. Otherwise, the dominant effect, dominant common residuals, those tend to work well, and you would apply those and figure out which one is giving you the better result. So with that, I think we're going to hold questions till the end. So Taha, I'll turn that back to you and we can take questions later.
Thank you very much, Frank. So our next presenter is Matt Hinshaw from FHWA's Office of Federal Lands. And Matt will be talking about how CMFs are used for project planning and identification at federal lands. So Matt, you should have the controls by now.
Thanks, Taha. Well, good afternoon. Good morning, still here on the West Coast. My name is Matt Hinshaw, and I'm a highway safety engineer at the Western Federal Lands Highway Division. I'll be going over how our highway safety team has been using crash reduction factors at federal lands highway. So here's the outline for my presentation today. I'll start with a brief introduction of our agency. Then I'll describe how we're using crash reduction factors for project development, as well as our agency's business measures. Finally, I'll request some feedback of you all to see how we can improve our process. So I'd first like to describe who we are here at Federal Lands Highway, as there may be many of you who have never heard of us. So you can see our mission there is improving transportation to and within federal and tribal lands by providing technical services to the highway transportation community, as well as building accessible and scenic roads that ensure the many national treasures within our federal lands can be enjoyed by all. We are a division of the Federal Highway Administration. Most of you have probably heard of or worked with your local Federal Highways division offices that work with all the state DOTs out there and local governments. Our Federal Lands Highway Division functions very similar to many of the state DOTs out there, as we provide project planning, project development, and construction administration of a wide variety of transportation projects on federal lands, as well as state, county, city, and tribal roads. The main difference from us to all the state DOTs and local governments is that we do not own and maintain the highways and roads that we have projects on. So you can see here my laser pointer out. So we're under U.S. Department of Transportation. So others like FAA and NHTSA, Federal Highways. We have the Federal Aid Program that a lot of you are familiar with the division offices. And then Federal Lands Highway has three main branches: Western, Central, and Eastern Federal Lands. And this is the map of the regions each of our three divisions covers. So I'm in the Vancouver, Washington office, and we have offices in Lakewood, Colorado, Sterling, Virginia, and Washington, D.C. And our projects are located throughout the country, so we have field staff dispersed throughout these regions as well. So where and who we work with. The programs our agency administers gives us a wide variety of project partners. As you can see there, the historic core of our program has been with our federal partners at the National Park Service, the Forest Service, and others, such as the Bureau of Land Management and Fish and Wildlife Service. In recent years, we've taken on more projects with fellow state DOTs and local agencies through the Federal Lands Access Program. So we have a lot of similar challenges when it comes to improving safety, as many of you face, with questions of how to improve safety for some very low to low ADT roads, the very mountainous, rugged, and hazardous terrain, and lots of competing interests for transportation funding. We also have very context-sensitive challenges in some locations where the aesthetics and preservation of the nature of the land is very important. So moving on to how we are using crash reduction factors here at Federal Lands. We'll talk about the CRF spreadsheet we use, how we use it to calculate the preliminary and final CRFs, while promoting proven safety countermeasures to drive safety improvements. And you've probably already noticed we use the CRF terminology a bit more here at Federal Lands. It's easier to communicate with others when you're talking about crash reduction with some people who may not be as familiar with CMFs and the like. So similar to what some or many of the state DOTs out there use for their highway safety improvement program, we have a list of our most commonly used CRFs that we have included in our worksheet. The list is based primarily off the CMF Clearinghouse, but also includes some other sources of CMFs, such as the desktop reference and other sources like Federal Highway's Everyday Counts literature. We've strived to be consistent on the types of crashes and severities of crashes that the CMFs apply to, with a goal to have the total project CRF apply to all crash types and all severities. As many of you know, there isn't always the ideal CMF that you're looking for as far as type and severity. So it's not perfect, but as we'll see, it is serving a purpose for our agency here. So we calculate an improvement CRF for each improvement type on the project. So I've got a hypothetical project shown here with our spreadsheet. And for this project, we are looking at installing advanced curve warning signs. And so we have the CRF shown here, which these should be shown in a percentage. So we expect a 30% reduction here for installing advanced curve warning signs. And we apply a basis of length so that we can calculate an improvement CRF and then apply that to the total project. So for this case, we're estimating that the curve warning signs on this project will give a crash reduction of 2.3% overall for the project. Each applicable project safety feature is input into the worksheet, and the resulting total CRF for the project is determined based on the top three most effective CRFs. And following Frank's presentation here, we're going to maybe want to complicate our spreadsheet a little bit. We were joking about that here in our room locally. But each applicable project safety feature is input here. And so we've also added in the safety edge for this project for the whole length of the project, results in an 11% reduction in crashes. And lastly, we have an improved guardrail CRF as well for, I just put in half the project here, so 22% becomes 11% here for the project improvement CRF. And again, the top three CMFs are used to calculate the resulting total CRF. In this case, I just have 3 entered, and our resulting total project CRF becomes 22.6%. And like I mentioned, we'll be taking a look at Frank's presentation and seeing what we may want to take and use here to improve this process. But we'll see how this has been beneficial for us as it is. So when are we calculating the project CRFs? First, we want to calculate the project CRF as we develop the preliminary engineering milestone, typically a 30% plan set. Our safety engineers provide early recommendations for safety features to be included with our projects based on the project's traffic, existing safety concerns, the proposed geometry and roadside design, and context of the roadway. Even if exact areas of barrier and, say, the use of warning signs are not fully developed by 30%, or it's known that the alignment may shift some, the preliminary project CRF is estimated to help show the relative effect that the project will have on reducing crashes. By calculating the project's preliminary CRF and including with the 30% milestone review documents, our project team and our partners, such as the National Park Service, Fish and Wildlife, state DOTs, or counties, can have a productive conversation on how the project is helping reduce crashes and identify further countermeasures or other ways to improve safety and operations on our projects. After project development is complete, our safety engineers update the crash reduction factor worksheet to determine any differences from the preliminary countermeasures. The final project CRFs then get used to determine our business measure. If a safety feature dropped out of the project unexpectedly, we can review why this happened and see how we can prevent that from happening next time. So now I'd like to go over how we are looking at our project CRFs at a program-wide level. For a number of years now, we've had a business measure at each of our 3 divisions to track our overall crash reduction factors. In order to combine each project's crash reduction factor, our team has recently begun weighting the CRFs based on factors intended to get a sense of the exposure of the project to the traveling public, so that projects that are longer and have higher traffic have a more significant effect on our total weighted average versus shorter projects with lower traffic. We do this by using the project ADT, length, and the project CRF to get a sense of its exposure, and you can think of that as being similar to calculating a crash rate. So this is what that looks like. We multiply the project ADT times 365 days per year times the project length to get a vehicle miles value. Then we multiply the project CRF times the vehicle miles to get that overall CRF vehicle miles value. To get the overall weighted total CRF, we sum all the project's CRF vehicle miles factors and divide by the sum of the vehicle miles factors. And the resulting number is then the total program crash reduction factor. For this last fiscal year, this is an excerpt from our summary spreadsheet that shows the individual project CRFs, shown here on the left. The project name is shown here, project number, the project length, short description, and then the ADT. And we're also showing the intermediary calculations then with the vehicle miles and CRF vehicle miles here. And we typically report on this measure at the end of each quarter. So we show the weighted average for the quarter down here. So quarter 4 of fiscal year 19 was 13.9%. And then the final weighted result for the year is calculated down here, and we had an 18.1% total reduction in last fiscal year. You'll notice some not applicable shown in gray here. There are some projects that we do not calculate the CRF for due to the nature of those programs. For example, our emergency relief for federally owned roads, ERFO program, typically limits us to restoring the original conditions before the disaster, so safety improvements are rare in those cases. Some of our other projects may be parking lot enhancements or geotechnical stabilization projects, so traditional safety improvements are generally excluded from those as well. So for fiscal year 2019, our division surpassed our goal of a 15% overall crash reduction factor due to the exposure of our biggest project on US 20 in Oregon with 17,500 vehicles per day and a larger CRF with multiple safety features on the project. That project allowed us to meet our goal itself. Without it, it would have been a 7% swing downward last year. So in summary, there are, of course, some advantages and disadvantages to note with our approach to using CRFs to determine a program-wide factor. On the positive side, it's a reasonable method to track our safety improvements and help drive additional safety features during project development. By getting the safety countermeasures identified early in the development process, we have time to consider adding countermeasures before the project scope is fully locked down. Once the individual project CRFs are determined, it's just a matter of organizing the data in spreadsheets to calculate an overall division CRF based on the weighting factors. So the weighting and combining part is pretty simple. This approach provides our agency's leadership with a business measure that helps acknowledge the work our agency does to improve safety on our projects and support Federal Highways goals. We can also filter the projects by our different program types or project types, such as rehabilitation versus reconstruction, to demonstrate how well we are doing with those programs or types of projects. There are several disadvantages or limitations to note as well. Our goal with this procedure is certainly not to split hairs, and we know this process is definitely not a research-grade university analysis, but we're instead shooting for a practical way to use CRFs to get a gauge of how our program is doing. As mentioned before, we're sometimes combining CRFs with different crash types or severities into one overall CRF, so there is certainly some error there. The basis of length is needed to resolve individual countermeasures into a project-level CRF, but that can be subjective when we're estimating these. Some of the ADT estimates that we use on our projects are also sources of error, and that does come into play with our exposure calculations for the weighted average. But again, we're just looking to get a relative measure of the project's exposure effect, so lower to higher ADTs across the projects will help smooth that error out. Other challenges that some of you likely face are that some important countermeasures, like refreshing pavement markings or replacing with more durable markings, have a shorter life and require maintenance, something this isn't taking into account. It can be a challenge to determine how much credit to give for safety features like pavement markings, especially if the road already had some degree of pavement markings before the project. Finally, we try for consistency in our approach to calculating the project CRFs, but there will always be some differences from safety engineer to safety engineer when determining the project crash reduction factors. So lastly, I'd like to actually turn it around and at the end of today, at the end of the webinar, ask the audience for feedback on this approach for calculating an agency-wide weighted average crash reduction factor. We're certainly curious to know if anyone out there is doing something similar, to understand how your agency's projects are improving safety. Maybe it's at a district level or a region level, or maybe you actually rolled all the way up to a statewide level. And if so, how do you do it, and are there any best practices out there? And we'll be looking at some of what Frank had gone over in the presentation preceding mine and seeing how we can improve our method here while still trying to make it a practical way to compare CRFs across our project and ultimately measure to see how our program is doing. So overall, using CRFs is one way our safety team at Federal Lands Highway is working towards Federal Highway's goal to reduce transportation-related fatalities and serious injuries across the transportation system. And I'll be happy to take any questions at the end of the webinar and welcome feedback on our approach to using CRFs. That's all I had.
Thank you very much, Matt. So our next presenter, which is our last presenter of the day, would be Shanshan Zhao from University of Connecticut. And Shanshan will be talking about linking to the CMF Clearinghouse through our new API. So Shanshan, you should have controls by now.
Okay, Taha, can you hear me?
Yep, we can hear you fine.
Okay, cool. All right, good afternoon and good morning, everyone. So my name is Shanshan Zhao. I'm a research scientist working at the Connecticut Transportation Safety Research Center at the University of Connecticut. So I'm very glad to be presenting today and introduce how we have been using the CMF Clearinghouse in our Connecticut roadway safety management system. So just a quick introduction of the background of the project. The project is sponsored by the Federal Highway and Connecticut Department of Transportation to implement the 6-step safety management process as recommended in the first edition of the Highway Safety Manual. So as many of you might be familiar with this already, so it includes network screening, diagnosis, countermeasure selection, economic appraisal, project prioritization, and safety effectiveness evaluation. So as a product of this project, our team have developed a web-based application, which is called Connecticut Roadway Safety Management System, or CRSMS. So this is a interface of the first analysis module in our screening. So you can see generally all the modules look like this. You'll see this further when I start demoing some of the components. But here you can see that we have two major components there. One is the data management component, which we use for data management, processing the input data so that the data can be used for further analysis. We have another component, which is the safety analysis component that has the 6 modules from network screening to all the way to safety effectiveness evaluation. So for today's presentation, I'm going to focus on one is how we have been managed to use the CMF Clearinghouse data and to use the API to keep our CMF Clearinghouse CMF data in our database up to date. And the other is how we have been using those in the analysis. So as we mentioned earlier, before we basically think about this, before we can select any countermeasures or consider any countermeasures that might be helpful to reduce crashes at a location, we'll need to figure out where are the most critical locations in our on our roadway network that have the high risk potential for safety improvement, which is the network screening. Which is what the network screening is doing. And after we figure out the high potential locations, we wanted to dive into those locations and take a look at the crash patterns at these locations, what might be the factors contributing to the crash patterns, and what might be the safety issues at those locations. So once those are identified, then we can move on to the CMF Clearinghouse or move on to other sources of countermeasures that the agency usually considers and compare and select the countermeasures that make the most sense. So in our tool, we have this network screening module and countermeasure selection, diagnosis module built. This is just a screenshot of the result of a network screening scenario analysis. So you can see that we have, we'll be able to show the top 250 sites with the high risk potential for safety improvement, ranking them from the high risk potential to the low risk potential in your network, and then we'll also be able to show where it is and display the roadway condition at a particular location on the map. So I'll show a result like this. So this is basically the end result of network screening. So you'll be able to get a list of locations with a high risk potential for safety improvement, and then will allow user to proceed ahead with any of those sites and to further diagnose what's going on at those locations. And that leads us to the second module, the diagnosis module. So we have provided several tools. You can see that in the middle on this page, there are several tabs. One is the map showing where or showing the locations of the crashes at this site. So for this particular analysis, so it is a roadway segment running on I-84 between 77.79 mile post to a 80.74 mile post. So you can see how many crashes are there, where they are located on this map. And in the other tabs, you'll be able to, for example, from the crash data tab, you can take a look at each crash individually. Basically, any information related to the crash in the crash report, you'll be able to see it there. In other tools as well, crash summary statistics, test of proportions, collision diagram, crash tree. So all those are the tools that we've provided to the user of the CRSM system to facilitate with diagnosis. So at the end of this module, the diagnosis module, the result will be the expected result is that the user should get a good gotten a good idea of what are the issues at this location, what crash patterns are there, and what might be the factors that contribute to those crash patterns. So with those questions answered, and the user is ready to move on to the next module, which is the countermeasure selection module, and it is the one that I wanted to focus my demo on. So we can take a look at kind of a live demo of the countermeasure selection module. So we click this countermeasure selection module. You can see that those are the diagnosis reports that I have completed earlier. So we take the first one as example. So we come to this page, we can see that there are over 8,000 CMFs available. Those are all from the CMF Clearinghouse. You can see from the source column that these are all from Clearinghouse. And then we all know that CMF Clearinghouse is a national database or warehouse for the crash modification factors. So the tool will also provide a few other tabs, like this one is to summarize the diagnosis that the user has done in the previous module. User can also refer to the previous module by click this button. And this tab provides a summary of the statistics, characteristics at this location and what type of intersection and so on and so forth. So the last tab is a summary of selected countermeasures. We'll take a look later. So we go back to this countermeasure selection tab. I'll show you a couple of methods that how we manage to help user further filtering down the list from this over 8,000 countermeasures and CMFs. So let's see, left turn crash might be an issue at this location through our diagnosis. So we search left turn, and the list is, we can further can shorten the list by selecting, let's see, quality rating to be 4 and more, the category to be applicable to signalized intersection only, and so on. So now with a shorter list, we'll be able to go over the countermeasures available and select the ones that we think are the most appropriate to apply at this location. As you know, there might be multiple CMFs related to one countermeasure because it can be applied to different crash types, different severity, or the data may come from different states. So we choose the one that makes the most sense and most suitable for our case. Another way of searching is to use this filtering searching bar. So it searches against all the columns rather than just search against the countermeasure column. So very similarly, we'll go through the list and select the countermeasures and CMFs that are most appropriate for our situation. And another thing is that the user can use those CMF ID as a hyperlink to go back to the CMF Clearinghouse and to see more details about the study if they need to know more. And with those CMFs selected, we can take a look. They are summarized here in this tab. The more you select, the more bits obviously you'll see in this list. And with that, we can mark this countermeasure selection step as complete. So definitely the countermeasure selection is not complete. At this stage, we'll still need to move on to the next step. And with all the potential CMFs that we have selected here, we wanted to figure out which one or which ones are economically justified, which ones have a higher benefit cost ratio, so that will help us complete the selection of appropriate countermeasures. So as is not going to be the focus of my today's presentation, I'll just quickly show you a couple of slides that shows that our CRSMS tool has also this two modules. One is the economic appraisal, where the user can create one or multiple solutions that for each solution they could include one or multiple countermeasures, and then the tool will try to calculate the predicted benefits for the users. So those benefits are calculated based on using the project level specific performance functions, as well as queries of observed crashes at this location automatically from the tool from the previous 3 or 5 years crash history. So those information will be calculated automatically, and the user will need to provide the costs of the projects, and then the benefit cost ratio will be calculated, and then different solutions are compared, and the user can make a selection of which ones are have the highest benefits. And then once those solutions are economically justified, the users can move on to the next module, which is to prioritize projects within limited budget. So that is the kind of the overall of how we have been using CMFs, using the CMF Clearinghouse data in our analysis. So our team are very lucky to be one of the first test users of the CMF Clearinghouse API this spring. So we've been so basically API. So it's, as many of you may know, that it really is a kind of tool to return data when a client requests such data. So so we have been provided several formats of API, including JSON, XML, Excel, and so on. So we end up with using the Excel format because so it turns out that Excel format is the most compact and the easiest to parse at the moment that we started testing. That's a few months ago. Maybe the situation is different, and maybe it depends on what your application is. So, but we found that we're pretty happy with Excel API and format of API. So our developers have been using kind of a process like this. So we parse the data using the .NET Open XML library, and we parse the data into a hierarchical structure. So by hierarchical, I mean like the data, the CMFs are nested with the countermeasure. So one countermeasure could have one or multiple CMFs. So this is the hierarchical structure. So we then populate our database with those parsed data, and then we execute a database routine like this. Make sure that we will be able to recognize the data comes in a hierarchical format as we want them to, and we will be able to update the CMFs. If there are any changes to the existing CMFs, we'll be able to pick that up and update that in our database. If there are new CMFs added since our update last time, then we'll be able to add those CMFs to our database as well. So we'll also in our tool also allow users to add their own customized CMFs. Maybe those CMFs are agency-specific CMFs that have been recently developed that are not yet in the CMF Clearinghouse. So the user will be able to add those customized CMFs through the tool, and will be able to use it in the countermeasure selection module as I demoed a few minutes ago. So so this is the procedure how we kind of use the API. I'll show you quickly a demo of what it looks like to a general user, like not a database admin. So as I mentioned earlier, we have a component which is called the data management module. So in this data management module, one of the tool is to kind of periodically update the underlying CMF data. The purpose of having this component is that rather than relying on a dedicated database administrator for them to kind of update the data, basically a high-end user or admin user of this tool, they will be able to interact with this interface and update the CMF, update our database with the latest CMF Clearinghouse without bothering any developers or database admins. So we go to this page and we'll see that this lists the over 8,000 CMFs from the CMF Clearinghouse database, and the admin user will be able to, as I said, use the API to update our database and make sure that it's synced with the latest CMF Clearinghouse data by just clicking this button here at the bottom. So it says import CMF Clearinghouse countermeasures. So this is just kind of keep our database just one click away from the latest and greatest CMF Clearinghouse resources. By clicking those, the underlying logic is utilized. It kind of grab the API and update the data, update our database with that. As I said, also at the bottom, you can see that the admin user can also add their customized CMFs if they do have those in their agency. So this basically kind of wraps up of how we have been updating our data with the CMF Clearinghouse API and how it looks in our data management module. So I think with that, that basically kind of wraps up my presentation. This is a collaboration effort between Federal Highway, Connecticut Department of Transportation, our Safety Research Center, and our partner VHB engineers. So this is my contact information. I believe we're going to have our question and answer session in just a few minutes. So I'm happy to take any questions you have. And with that, I'll turn that back to Taha.
Thank you, Shanshan. Thank you for the presentation. So thank you for participating, guys. We have a bunch of different questions, that have been entered through our questions box. So we'll try to go over them randomly, So Caroline, do you want to start? Maybe and then we all can answer. So first of all, for all the panelists, Frank, Matt, Shanshan, and Karen, if you want to unmute your phones, so we can all, answer and chime in any questions, as we want to.
Okay. So first question is, are all of the detailed studies used to create the CMF available free of charge?
It depends, on where the study is. A lot of journals, like if you're part of an education institution, a university, or if your company have access, to those journals, then yes, you can download them. But we do not provide any of those studies from any of the refereed journals on the clearinghouse. If it's a federal highway report that's in the public domain, of course we provide a link to that study in the clearinghouse, but not a link to, but not the whole PDF to download, for any of the refereed journal papers. So yeah, so you'll have to figure out, from your own institution if you can access it using your institutional logins, if you have access to that.
Okay, and another general question: under reverse treatment, is there any instruction guide on when they can be interpreted? Any difference between before/after CMFs or cross-sectional CMFs?
I don't believe there's any difference between before, after, or cross-sectional CMF. It's the same methodology. As far as the guide goes, I don't recall seeing any guide, that's out there, that outlines, how to use reverse treatment and when in what situations. But I believe it's pretty general, like if you have a CMF, you can always go ahead, and apply the methodology that we went over in our first presentation today, and calculate the reverse treatment effect, using that.
Okay, another question, how do you use the star rating? What does it mean?
Well, so star rating pretty much, it tells you how robust the study that developed the CMF, or how robust the CMF in itself is. And star rating, it has various components that goes into it. So we rate based on the study type, we rate based on the standard errors of the CMFs. We also rate the sample sizes, the number of states, or the number of different jurisdictions used. So yeah, so basically, if you see it as a 5-star CMF, it just shows, that it's a robust CMF. It has used a robust study design, has used a good sample size, and has low standard errors, compared to a 1-star CMF, which would not have used a robust study design, would have used less data, and yeah, that's pretty much it. And would have had high standard errors as well,
Okay. Another question is, to decide which combined effect method that could be used, you mentioned that the multiplicative method could be applied if the CMF 1 or more is greater than 1. What is meant by CMF greater than 1? Well,
so that's a basic question, guys. So a CMF of more than 1 would mean a negative effect of a treatment, which means the treatment is in fact increasing crashes, whereas a CMF of less than 1 would mean a positive effect, which means the CMF or the treatment is successful in lowering the crashes at the site.
Okay. This question is for you, Matt. Why would there have been a decrease without the effects of US 20 improved safety?
Sure. I was just highlighting that one project resulted in about 7% of our 18.1% total for the year. So most of our other projects had a lot lower exposure, and they could have had high CRFs for the individual projects, but again, if they were lower traffic or say an intersection improvement, so a much shorter project. It was just that US 20 project was about 12 miles or so with a lot of traffic for the types of projects we do at Federal Lands, and had a lot of safety features, so it had a bigger impact on our overall weighted average.
Okay, thank you. And there are a couple of questions related to the difference in nomenclature between CRF, CMF, SPF. The question that sums it up well is, can you elaborate the difference between CRF, CMF, and SPF? Karen, you want to take a stab at that?
Yep, so crash modification factor is a quantitative measure of the expected effectiveness of a countermeasure expressed as a decimal. So 1.0 means that there is no effect, and if the CMF is less than 1, then that's the expected reduction in crashes. And so a CRF is just the opposite. So 1 minus CMF is the CRF. And SPF is a safety performance function that estimates the predicted number of crashes based on, typically they're a function of AADT. So hopefully that helps. There is additional information on the CMF Clearinghouse about many of these questions. So if you go to the CMF Clearinghouse under the About the CMF Clearinghouse header, there is a link to FAQs that it has more detailed answers to this and some of the other questions that have been asked.
Thanks, Karen. So 2 questions coming your way, Shanshan. The first one is, who is the intended audience or users of the Yukon tool?
Sure. So currently the tool has been used actively by Connecticut Department of Transportation, particularly the safety engineers and just general engineers who need to kind of plan for a project or identify issues with or potential safety issues, so on and so forth. So primarily by Connecticut DOT. The tool is also introduced to local agencies and municipalities so that they can use this tool for identify locations for safety improvement in their jurisdiction or use the tool for diagnosis. So basically the tool is developed based on Connecticut DOT's data and primarily serving Connecticut DOT and local agencies at this moment.
Okay, and another question for you, Shanshan, is what is the API address, and are there any documentation on how to use the API?
Yeah, sure. I'll try to answer this question. Maybe Taha, if you know anything more about this, you can add. So we started testing this API in April. So we got the direct URL for this API. Our developers got this from our primary contact, Daniel Cotter at UNC. So I don't know for sure that whether the APIs are publicly searchable from the CMF Clearinghouse. So basically, our kind of experience is to work directly with the CMF Clearinghouse and maintenance staff.
Shanshan, I'll just add to it. So we do have a data download page that's available publicly on the Clearinghouse website. So once you're at the Clearinghouse website, if you go under the About Clearinghouse header, there's a thing at the very bottom. It says Data Download. So once you're in there, you can download the latest snapshot of the data, from the Clearinghouse, and that is something we update, on a monthly basis at the beginning of each month. So when you download, you're pretty much, for sure, getting the latest snapshot, or snippet of the data that's available on the Clearinghouse, and you should be able to download, I believe, in Excel or CSV format, from there.
Okay, great. And we have quite a few questions, and we're not going to be able to get to them all today, but we're going through to look for a couple more. But just as a reminder, we will answer these questions and make them available after the website. Yes. And if several folks have asked too, will the presentations be available? And yes, the recording of the webinar will be available in the next several weeks, so keep your eye out for that. And glad that you are all finding it helpful. Here's one that says, any thoughts on when HSM version 2 will be public?
That is a very good question.
Maybe even Karen Scurry may be in a better position to add, maybe answer the question, I'm wondering.
Yeah, so not really. It seems to change all the time. I think maybe the last that I heard is 2021. I'm not sure. Sorry, I can't be more helpful at this time.
Great. Okay, so I think we'll stop the questions at this point. It's only 3:25 right now, roughly. So Karen, I will transfer it over to you to close out the webinar with some closing remarks and some more slides, that you have.
Yes, thank you, Taha. So before we wrap up, I just wanted to share a couple of things with you. First, a couple of additional resources that might be helpful as you continue to use and apply crash modification factors. So there are, we just completed the development of 2 videos on analyzing the combined effect of multiple countermeasures. So this is, this will give you much more detail on what Frank presented on today. So there are actually 2 videos. The first part is on selecting the appropriate method, and then the second part is on applying each of those methods that Frank talked about today. So it says coming soon because they're not quite posted to the website yet. They're in queue to be on the website. So as soon as they get posted to Federal Highway's website, we will link to them from the CMF Clearinghouse and feature them somehow on the homepage of the Clearinghouse. We also have a training on developing quality CMFs, and we have been in the process of updating that training course. And I was hoping that it would have been updated sooner than it is, but I think we're putting the finishing touches on it now, and we hope to have the next offering sometime this spring, so likely in the March-April timeframe. This is a web-based course. So you participate from the comfort of your own desk and computer. It has self-study components as well as web conference components. So it's a 4-week course, and I think it's something like every Tuesday and Thursday you attend an in-person web conference. So it is very demanding of your time, but the feedback we've had from this course is very positive. So if this is something that you're interested in learning more about, I would encourage you to review the course narrative and participate in the course if your schedule permits. And then the last thing, I think Taha mentioned it during his presentation earlier today, but we are available to provide technical assistance on any of the CMFs in the clearinghouse, or if you need help applying CMFs, please reach out to either myself or Taha, and we will direct you to someone that is able to help you with your CMF needs. You can go ahead to the next one. And then moving forward, there are 2 things that I just wanted to give you a heads up about. So they're coming soon. Again, not quite there yet. But over the past couple of months, we have been working on some improvements to the CMF Clearinghouse. I like to call this, it's a facelift. And then another more extensive improvement to the Clearinghouse is that we are going to transition to the rating criteria for the CMFs that will be used in HSM2. So I know there was a question about when will HSM2 be published, but we're going to move forward and use the same criteria as HSM2, and I'll talk a little bit about that in a minute. So I just wanted to first give you a sneak peek of what the CMF Clearinghouse will look like once the facelift is in place. So if you can go to the next slide. So the Clearinghouse will maintain all of the features that you know and love today, but we tried to modernize the colors, the web formatting, and those kinds of things, just to make it more visually appealing. So there are not any technical changes to the website, just the way it looks and feels. We're also adding what I'm calling quick buttons. I don't know if that's the right term for them or not, but if you can see it underneath of the search box, we're adding some quick buttons for frequent searches. So we're going to try to do some web analytics to see what things our users are looking for the most and highlight those there, so that whatever is the most popular thing, you can just click with one click of your button. And then also, a lot of folks like to just download all the CMFs from the Clearinghouse, and so we're going to add a quick button so that you can do that. That's that Browse All button. You can do that now, but it's not as clear as how to do that. So we were hoping to have this up today, but I would expect that it should be up within the next month or so. So I just wanted to give you a heads up so that you're not surprised the next time you go to the Clearinghouse and it looks a little bit different. Nothing really changed, just the look and feel of the website. The CMF Clearinghouse transition to the HSM2 inclusion criteria will be a much longer and more intensive process. And so for those of you that are familiar with both the CMF Clearinghouse and the HSM, the first edition of the Highway Safety Manual rating criteria, you know that they are different. And so there's a project underway now, NCHRP 1772, that is updating the rating and inclusion process for crash modification factors in the second edition of the Highway Safety Manual. And so we, Federal Highway, thought that this would be a good opportunity for us to align with the inclusion criteria in the Highway Safety Manual. And so we're going to take some steps over the next year or so to come in alignment with the NCHRP 1772 rating and inclusion criteria. This is a big change for the CMF Clearinghouse and all of you. And if you can go to the next slide, we want to make sure that we do this right. So we've developed a transition plan that describes some key internal and external activities that will occur over the next year or so. And so just a couple of things that I want to note. So for the internal facing activities, we hear from our customers, from some of you probably, that you like the star quality rating, you like that at a glance look to get a feel for the quality of the CMF, and so we're going to maintain that feature. We will have to develop a method of providing star ratings based on the new HSM2 rating criteria, and so we'll be working on that over the next couple of months. And then as an external facing activity, your input is very important to us as we go through this process, and so we'd like to hold some stakeholder calls so that we can better understand how this change will affect you. This is also a good opportunity for us to identify any concerns or potential enhancements that might improve your navigation and ability to search the clearinghouse. So I would just offer that if you would like to provide input to this process, to please let me or Taha know. We'll be on the lookout and searching for folks to participate in these stakeholder calls over the next couple of months. So you can either email us directly, or I think there might be a question on the evaluation to provide that input as well. Otherwise, just stay tuned for additional information. We will be sure to keep you informed and up to date as we move throughout this process. So to wrap up, when you exit the webinar today, you will have a brief survey. A brief survey will load. We would very much appreciate your feedback on our performance from today's webinar and any suggestions that you have for future webinar topics. We take a very close look at your input as we're planning the next year's webinar, and as well as other outreach and education materials. So please take the time to respond to the survey today and tell us how we did and what you would like more of in the future. And then I know you guys are all interested in how you can get PDHs for today's webinar. So following today's webinar, you'll receive a follow-up email that will include a link to download a printable certificate of attendance for 1.5 hours of professional development instruction. If there are multiple attendees at your site, you can just forward that link to the other participants, and then they can download it and print the certificate with their name. And with that, I would just like to thank everyone for joining us today. Our presenters, Taha, Frank, Matt, and Shanshan, thank you so much for sharing your expertise with us today. Those were all great presentations. Caroline, for making sure everything worked properly behind the scenes, and all of you for taking time out of your busy schedules to join us today. I wish all of you a safe and happy holiday. Thank you very much. Have a great day.